So 7.7 really doesn't have a whole lot to do with 7.6. 7.6 kind of stood alone. It was its own thing, but definitely remember it because that will be on the test. 7.7 is about inverses. When I say inverse, what do you think of? Opposite, kind of. Yeah. That's basically what an inverse is, and we're dealing with functions and relations. If a relation pairs element A of its domain, is domain X or Y? Domain is X. Very good. Okay. To element B of its range, which is Y. The inverse relation pairs B with A, so it does the opposite. Instead of A with B, it's B with A. So if AB is an ordered pair of the original relation, then BA is an ordered pair of its inverse. Another way to see this are these figures over here. For the original, here's your domain, so there's all your x's. There's your range, so there's all your y's. And for the inverse, they switch. The y's become the x's become the y's. All right, so x and y just flip-flop. Another way to say this is if the range of the relation, or the range of the relation is the domain of its inverse. And the domain of the original relation is the range of the inverse. So you can just switch them. Whatever the x's are of the original become the y's of the new one. Whatever the y's of the original were become the x's of the new one. So we're going to start out pretty simple with just some coordinates. Okay, so here is the relation M. This is our original, and it has 4 coordinates. -1, -2, which is already graphed down there for you. 0, -1, also graphed. 1, -1 is graphed, and 2, -2 is graphed. So for the inverse, we take that first coordinate, 1, -2, and we flip it. So now it's -2, -1. All right, and you can graph that. So -2, -1 is right there. What will your next coordinate be? -1, 0. Yeah. -1, 0. As Levi said, the next one will be -1, 1. So we've just flipped the x and y. I graphed the first one totally wrong. You are right. Sorry. Okay, and then the last one, what's your last point going to be? -2, 2. So all we did was this entire, like, y row became the entire x row. The entire x's became the y's. As you can see on the graph, they are very similar shapes. So this one kind of makes a half circle pointed down. This one makes half circle pointed to the left. All inverses are a reflection over this dotted line. This exact one. So any inverse, if you folded the paper on that line, the inverse and its original would lay on top of each other. That line is called y equals x. You should remember that. Maybe that will get you some points on a test sometime. The inverses are a reflection over the line y equals x. It's always that same diagonal. All right, any questions so far? Just switch x and y. Just switch x and y. All right, we're going to go a little more complicated in that we're not dealing with coordinates. We're going to deal with an equation. Okay, so we have an original equation, y equals x squared plus 3, and we're supposed to find its inverse. There are two steps. The first one is to switch x and y. That is not pretty. Okay. Try again. That's an and sign. Switch x and y. Okay, so my step 1, instead of y equals, it will be x equals. Instead of x squared, it will be y squared. And then I still have my plus 3. Next step is, like we would normally do, we need to get y by itself. So solve for y, or get y equals, however you want to say it. All right, so if I'm supposed to get this y by itself, let's move the 3 first. So I'm going to subtract 3 to the other side. So x minus 3 equals y squared. Okay, and how do I get rid of that squared? Square root. Yes. To get rid of a squared, you take the square root. If we take square root of both sides, what do we have to write in there?
The actual value.
What'd you say? Plus minus. All right. So plus minus, and we're actually done now because square root and squared cancel out. So we have y equals plus or minus square root of x plus 3. Minus 3. Oh my goodness. Having problems today. There's your answer. So all you have to do is switch x and y, solve for y. Switch x and y, solve for y. Okay? On the back, we are going to graph these. All right, so the original was y equals x squared plus 3, and the inverse, y equals plus or minus square root of x minus 3. So I'm going to start with the less complicated one. I'm going to start with x squared plus 3. And I'm going to do it without a calculator, because I can and so can you. Let's pick a few numbers to plug in for x. What do you want to plug in? 2, okay. Okay, let's go 2, 1, 0. All right, if you plug in 2, let's see, that's 2 squared plus 3, which is, what'd you say? 7. All right, if you plug in 1, 1 squared plus 3 gives you 4, yep. And then 0 squared plus 3 gives you 3. Okay, I'm going to graph those 3 and see if I can make a graph out of it. Okay, so 2, 7, 1, 4, 0, 3. Let's do another one. Let's do -1 to see what it does. So -1 squared plus 3, what does that give us? 4 is correct. You with us, Big K? 4. Okay, so -1, 4. Now we're seeing the shape of our parabola, right? Parabola. So, do you see where the vertex is? I want a different arrow. This one. Yep, there's our vertex. These 2 points are reflections of the other. So this one we could also reflect over here. And now you can draw your graph. That was almost good. The next one will not be as much work. Why? Because inverse, all you gotta do is flip the x's and the y's. So for the next one,
Starts at negative.
not quite. Okay, x minus 3. So the next one, if 2, 7 was a point on the original, what will be point on the inverse? Somebody said it. 7, 2. Okay, what will the next point be? Let's see. 4, 1, 3, 0, 4, negative 1. So graph all those. 7, 2, 4, 1, 3, 0. Woo. And you can figure out where the last one would be as well. So you can see that if you folded your paper along that diagonal, those two parabola shapes would land on top of each other. But one is actually going sideways. Any questions? Okay, so if you wondered like what would make a parabola turn sideways, it's the square root instead of the squared. That's what makes it go sideways. No, just that this one's part of it. Okay. Any questions? Okay. So the next part, the computer isn't really helping us out. Okay, it says the inverse of a function f is denoted by, it actually says f to the negative 1, though it is very hard to see on your paper. Okay, so if you want to like rewrite it out, up top, f to the negative 1. I need to figure out how to fix that. Okay, f to the negative 1. You read f to the negative 1 as inverse of f or f inverse. Okay, inverse of f or f inverse. The notation f of x is used for functions. Remember functions, there's only one y for every x, and it passes the vertical line test. That makes a function. Okay, so f of x is specifically for functions. Remember that f inverse may not always be a function. Like here, this one is not a function, so we could not use f of x for it, right? Because it's not a function. And of course, the last problems, they're going to ask you whether it's a function or not. Says, consider the function f of x equals square root of x plus 1. Okay, so this one is a function. Okay, if you want to graph it, you would see that it would be like this. It's like half of your sideways parabola, which makes it a function because it doesn't have the under half. It says find the domain and range of this function. Okay, we have two things that we kind of can't happen in our problems that would make our domain odd or different, not all real numbers. Okay, the first one is the denominator cannot equal 0. Okay, that's the first one. We don't have a denominator here, so we're not worried about that one. The next one says here with the stars is that the radicand cannot be negative in order to produce real numbers. Okay, we're not looking for i's. Right, Clay? We're not looking for i's. We want whatever's inside the radicand to be positive. So that is going to affect our domain. So for our domain, x plus 1 needs to be positive. So we write that as greater than or equal to 0. Okay, we need to get x by itself, so move 1 to the other side. So we subtract 1. So our domain is going to be real numbers, but x has to be greater than or equal to -1. There's your domain. That radicand is also going to affect our range. For our range, a radicand will only produce positive numbers. So our y's, as you see by my graph that I drew that you could see on your calculator, the y's never go below that axis. So y's have to be positive. So we write that as real numbers where y is greater than or equal to 0. If you were doing a parabola or something, it'd be all real numbers for your domain and your range. But when you have radicands and denominators, that's when it gets complicated. All right, so there's your domain and your range. Part B says find F inverse. Okay, so we're going to do what we did on the front page. And the first thing is switch x and y. All right, so we can replace f of x with y. So instead of y equals square root of x plus 1, I'm going to write x equals square root of y plus 1. Everybody follow me there? I didn't lose anybody? Okay. Now, step 2 is that we're supposed to get y equals. So how do we get rid of this square root? You are correct. Square both sides. So that gives me x squared equals y plus 1. We're almost done. Yep. So y equals x squared minus 1. You could write it as f inverse equals x squared minus 1 if you would like to, since that's what it asked you to find. Both of those are correct answers. Okay, so either one would be correct. Almost done. So for the domain and range of f to the -1, f inverse, you have already figured it out. Okay, you need to the domain of the original becomes the range of the inverse. So range is going to be real numbers, but instead of x is greater than or equal to -1, it's still range, so you write y is greater than or equal to -1. So if you want to draw like an arrow to help you, dotted line or something to kind of show you what happened. Okay, so then the range from the original one gives you the domain of the new one. All real numbers where x is greater than or equal to 0. Don't give yourself extra work that you don't need to do. Okay? Just do all the work up top, figure out the range and the domain, and then switch them for down here. You have to do it that way. If you were to just look here and figure out the domain and range, you would actually get it wrong, because that's a parabola. That equation is. But the deal is that we're doing the inverse of this thing. If we flip this thing over, it will not give you a whole parabola. It will give you half a parabola, which is correct. You're supposed to have half a parabola. So that's why your domain is only half of your x's. It doesn't include negatives. And your y's are, again, just above -1. So, what do you think? Do you think the inverse is a function or not? Yes, no. Why do what makes you think yes or no?
Because you can graph it.
Because you can graph it? Okay, what does it look like if you graph it?
The parabola.
It's a parabola and it's only, is it a whole parabola?
The whole parabola. Right.
It's going to be a half of a parabola and it's going to look like that. Is that a function?
Yes.
Yes. Okay, because you can do the vertical line test and it'll never cross more than once. So yes, it is a function. Okay, you can graph it in the calculator to help you.
It's a full parabola. X squared minus 1.
Okay, but
But I can cut it in half.
yeah, this is what makes it half of a parabola, and okay, because that is the inverse of the original. So since we're talking about inverse, it has a special domain, and it is only half of it. And I think probably somewhere in your calculator you could like put a domain in there, but as far as it knows, it can graph whatever it wants to. Okay. You all right? Any questions? All right, so like I said, there's some graphing. You have, let's see, what time do we get out of here? 43? You have like 20 minutes, which is good. You can get a lot done. So take advantage of your time.